Thank you. Yeah, I'm Falk Schaefer, part of Accenture's global technology innovation practice and focusing on service robotics. And I'm also leading a team of IT/OT software engineers in Germany. So my presentation is about robots are coming into the wild and full-stack roboticists be ready. And that's all. Those two aspects I will also talk about in the presentation. First of all, a little bit recapping and adding to what Christian in the previous presentation mentioned, what is happening on the technology space, what trends do we see, what is happening on the market side, and also why we see what we call robotic reality capture, using a robot as a mobile sensor, why we see this as one of the first areas where we see robots in the wild being adopted in enterprise environments. And I will also show two projects we've been involved in, talking about that, one with a drone and one with an elect robot used for inspection and autonomous data acquisition at industrial sites. And then I will go a little bit into the technology side and explain what we see there, what tools are usually used, and what skills are needed in order to build such solutions. That's maybe interesting for a lot of people working in that space, from software side, from cloud side, from electrical engineering side. So these are the two aspects I will cover. So let's talk about robots in the wild. It's a technology trend we already had 2020 in our tech vision. And it basically refers to that robots are coming outside of their industrial cages, meaning they are conquering environments that are made originally for humans, right? Very much less predictable than the factory shop floor, than the production floor. And that's happening across the board. Anybotics here is a good example of this progress we have seen in the last decade in core robotics technology, right? So this robot is walking at our innovation center in Essen. Outside, that's a picture taken. But also, for example, Boston Dynamics Spot, right? So elect robot able to climb stairs using latest electric drives, latest control technology, latest sensor technology, and able to operate autonomously using navigation, localization, to a point where we see this now ready for enterprise adoption. And of course, robotics as such is not new, even outside the manufacturing floor. If we look at pipeline inspections, they have been sending pigs, small robots through the pipe to inspect stuff already for decades. If we look at drones, most companies have done their experiments with drones. But what we now see is a next stage, and this next stage is characterized through higher level of autonomy. And this is actually a game changer. So instead of having a robot as a measurement device that needs to be controlled remotely by a human, and steered, we have a one-to-one relationship between somebody controlling the robot and the robot moving. We are now moving to fully autonomous operation. That means drones, robots can start and end missions autonomously without or only with minimal human supervision. And that's actually the game changer, where we see new levels of business adoption being made possible and viable through that. You can think about it like the robot is becoming an actual co-worker. Obviously not as capable, as powerful as a human, but certainly taking over some tasks fully on its own. Think about it like a working dog. So like a hunter security guard has a working dog taking over repetitive or dangerous tasks. The future operator of such an industrial plant will have a fleet of robots at his disposal in the future. And this is happening across the board, what we call service robotics. So robots being not used for manufacturing, but for services. So usually where humans do those today, and augmenting humans, not replacing them. This is happening across different industries. If you think about retail, we've heard before, for example, on the top left, you see a drone flying at night through the warehouse to do inventory scanning. If you look at Amazon Scout or Starship, you see the small delivery vehicles. They're already in test operation in US cities, right? and they are already used on campuses and industrial plants to deliver spare parts or probes from A to B. If we think about agriculture, there are a lot of robots already to do vegetation management, surveillance, monitoring the soil, monitoring the growing progress, harvesting machines that can be used at fruit plantations and so forth. Or if you look at restaurants, on the top right, you see the robot serving drinks in a restaurant. Or look at cleaning, disinfection, ultraviolet disinfections, or other cleaning robots that are used more and more, which can perform fully autonomous certain tasks. So overall, the service robotics market is expected to grow to $180 billion in 2025. So that's really substantial business and investments going in there. Let me a little bit explain where we see this on the maturity curve. We differentiate a little bit between normal, simple digitization, moving away from paper to some digital stuff, and then on the far right, full adaptivity, so meaning systems that can autonomously trigger actions and do stuff. And we see right now the robots in the middle section to accelerate this progress from creating more transparency, getting more data, creating more understanding of what's actually happening at the moment. And that's for one reason, because from a technology maturity curve, we are just not there yet to have that reliability in the robots today to actually physically manipulate stuff. Probably you know from your own products and projects, it's very hard to engineer something to a point where it's actually ready for the real world, for the real life. And that's so true for robotics. Look at Roomba. It took 12 years to develop a very simple cleaning robot in the consumer market to that price point and that reliability that they actually hit the market nerve. And that's true in this space. And that's also why we see the first adoption of those robots in the wild being used as a mobile sensor. So this is something they already today can do very reliably, very good, moving around, getting data for increasing transparency of what's happening. And this is also already powerful enough because there are a lot of tasks that are repetitive, that are dangerous, that are dirty across different enterprise application areas. For example, if you just look at the narrow scope of inspection of an industrial plant, for example, there are a lot of opportunities. So when we speak about inspection, we speak about a task where today human needs to physically check that something is still okay. So think about remote locations, offshore facilities. Do we really want to send people there, humans there, just to check that everything's okay regularly? Think about regular inspection walks today done 3 times a day. There are 3 shifts. Every shift, somebody walks around and just checks that everything's still okay. This is something we can very good automate very well today, and basically replace 50% of the work efforts going into such a task. And imagine instead of walking around the site with a clipboard, in wind and weather, you can sit at your office with a coffee mug and scroll through the data and images you get from the robot. And then think about inspections where today humans need to climb in, under, or onto something. Things that are dangerous, right? That are dirty, where people need to put on special safety equipment. We don't want humans to do those tasks more often than necessary, and often we don't find even people anymore who want to do those kind of jobs. So often it's not anymore the question if there is a business case for those kind of applications, but only how to get there. And what are the tasks a robot can do in that area? If we talk about reality capture, inspection, first of all, they can check that everything is still okay. So they have powerful sensors that can go at every location at the right point in time and check that everything is still in order, right? They can also read out analog devices, something that you would never retrofit to be connected or digitized at this point because those assets have been there for a couple of decades already. So they can take a look at those analog displays, read out the values, and that way you get a lot of more data than before. They can check if valves at the right position, for example, at a chemical site. They can collect additional data for maintenance purposes, for example, thermal information of heat exchangers to check if they are still efficient, need to be replaced. They can look at rotating equipment with a microphone because they have very characteristic sound profiles, and you might detect that something is going off before it happens. And then we look at things like a plant street view. So something from Google Street View, right? Having that, but on a daily or an hourly basis. So you can do regular scans, you can explore the site without being there remotely. And then we look at telepresence, so you can have a physical eye on the ground without leaving the control room, without leaving or even traveling to the site. And safety, obviously, is very important, and security as well. So they can even check the perimeter if there are some intruders, or check that safety equipment such as fire extinguishers and so forth are there. Let me speak about two projects we did. One is at the Hamburg Harbor. They have those container bridges, 50 overall. And today there are professional climbers coming in. The crane is out of order for 2 days. And then there are people on the ground, maintenance professionals who know those equipments, and they are guiding the climbers where to go, what pictures to take, and then in the end decide if there are follow-up maintenance tasks to be done. Obviously, that's the case for drone, right? And we implemented that, and there's real business value behind. You can save a lot of cost for those professional climbers. You can reduce risk, and you can also reduce the time you need for such an inspection. Yeah? So that's shown at the bottom. But the interesting part here from a tech side is not that somebody is flying a drone and controlling it, but it is fully autonomous. And that's where we see it going. So the drones can pick up fully autonomous, find the container crane, do the inspection flight, get the data that is needed, come back and land autonomously. And we got the flight permission from flight regulation there in Hamburg. And it's actually working, so it's a really working solution. That's one thing. And the other thing, it's end-to-end integrated, meaning we have a service now for scheduling and requesting this inspection. We have the flight operator platform where then fine-tuning is done, looking at the weather, communicating with the flight regulation, and the drone operator just needs to check that all the stuff is in order, put in the new battery, and then click a button and the drone goes off. And then Optelos for data management. So you get all the inspection data. We developed a custom corrosion detection algorithm that was quite easy because those are painted blue. So you see corrosion, red, usually very good. So that was quite simple in that case. And it's working. And then you get automatically a pre-selection of those images, and the maintenance professional just needs to look at the subset of this data and then can trigger automatically tasks for the maintenance teams in ServiceNow, which can then get their order to do this in the next week, right? So this is autonomous operation and full end-to-end integration where we see it going. And the other example I wanted to show you is our elect robot inspection. We work there with Robotics, it's a Swiss startup, and Cognite. Cognite is an IT/OT data fusion platform, and it's also spin out of a client engagement. It's an energy client. They have an energy plant, and that is a little bit remote, 6 kilometers away from a larger power station where they have a 24 operations team. So obviously the client was looking into how can we operate the site without having 24/7 operations team on site. And it's a plant that works with geothermal energy. So there's a lot of energy efficiency things and heating stuff to look at. So the process engineers were very interested to look at thermal information from the plant during operation, during different wind and weather conditions. And obviously, we could have put thermal cameras all over the place. It would have been very expensive. So we said, let's use a robot as a powerful sensor that can go to the right place at the right point in time to get that data that's needed and interesting for the process engineers. And this is where the showcase comes from. So that's the Elect robot. It runs fully autonomously. So you program once the inspection mission. It's supposed to do, use your thermal camera, use your normal camera, or whatever sensor you put on top of it, and it gets the data. And I want to show you quickly how it looks in the data platform that's connected to it. For that, I will share my screen here. So what we see here now is the Cognite data platform. And it's a 3D model of our innovation center in Essen. So I will now zoom in to in the building model, slide through it, and then go to the asset that we are inspecting. We have a little reactor here. There's some, actually, for showing purposes, it's just water heating up to 60 degrees and cooling down again, but with all the IT systems behind that you usually see at client systems. And what we see here now is I can click on the model. First of all, I have an inline display of what is the current temperature. And now I'm seeing the time series. And here I have the images coming also from the robot. So there's a thermal picture that wasn't heated up yet, but here you can see a little bit this reactor, right? And it has a certain temperature. Here is the PLC that's controlling the system. It also gets heated, right? So you have the data coming from the robot alongside the temperature data coming, in that case, from our OSIsoft historian database, where the PLC data is connected. So that's powerful stuff from the data platform side. You can connect your IoT sensor data together with the data coming from the robot. And I will also show you another asset. I'm looking for the fire extinguisher, so I can search for it. And it also regularly checks that our fire extinguisher is at the right place where it's supposed to be, so there were some reflections on the camera, but you can see that our fire extinguisher is where it's supposed to be, because it's an inspection point programmed in the robotics mission, and it could ring an alarm if the fire extinguisher is not present anymore. And in the 3D building model, you can also see the exit plan and also where there are supposed to be emergency exits. So that's also powerful from a safety point of view. And I want to show you something else. So we can also go to this street view image, and scroll into the 360-degree view in our innovation center. At that time, we went also outdoor where it was raining, and you can see 360-degree. So if you show that people at the plant, they also immediately see, hey, that way I can find out who stole my ladder from the construction site at that corner. I see it over there. But in the end, it's very interesting from the engineering side. You can merge the different models you have of such a building, of such a plant, from engineering, from construction to operations teams. All right. Back to the presentation. And obviously, we're looking also at not only as a playful tool, right, but what are the business value connected to it? And we looked at it not at the edge cases where you say offshore or a very dangerous task or stuff like that. There's clear business case for that, yeah. But we also looked at a normal scenario, a more scaled scenario of such a site. And we assumed we have a plant with 12 plants, in fact, that are connected, right? We have there 3-shift working teams, operator teams, and in every shift somebody walks around, right? We are saying you can save, let's say, 1.5 hours of those 2 hours of this inspection walk. And just by looking at those direct benefits of automating this physical inspection walk, we see a positive business case. Yeah? And then obviously there are a lot of secondary benefits. Just look at the labor shortage. All our clients tell us it's very difficult to find those people for those kind of jobs. Yeah? And it's clear going forward, they need to do the same task with less people, and that this is the future. And imagine also what you tell somebody, hey, you need to run around the site with a clipboard and enter data, or you tell them, hey, you will be a robot operator who's making sure that the robot can do its mission, and you're surveying a couple of robots. That's a completely different talk, right? So that's a little bit how our clients look at it and where we see the value of it. So the process is usually always the same. Yeah, if you speak about drone, if you speak about inspection robot, usually you have somebody who's responsible for such an inspection. And it can be a regular inspection, like with the container cranes. Hey, in the next 6 weeks, I need such kind of an inspection because regulatory safety, it's needed. Or you have an ad hoc inspection, for example, in that case, after a storm, there might be something damaged. Please, in the next 24 hours, do a quick scan that everything is in order. This is happening, for example, in tools such as SAP or ServiceNow. Yeah? And then you have somebody who's actually doing this inspection, or a robot coworker doing part of that inspection. And you have a platform to operate the robot or the drone, to do the fine planning of and allocating this inspection to a certain robot. And then you have something where you collect this data and analyze it and further process it. So usually there's some kind of another data platform connected to it. And usually also still some human in the loop, right? So in the end, a human decides if that's actually a problem. And that's with a normal machine learning AI project type learning, where the more data you get, the better the algorithms work. But usually those sites we get into, there is not a lot of data because people have been doing this for years, and it's all in their head. So it's usually a longer period where we need to get this knowledge, this experience out of the heads of people into more formalized decision-making and algorithms. And that takes a little bit of time. And then you trigger maintenance tasks, again, that pop up in SAP or ServiceNow. So contractors or the maintenance team can take care of it. So tech-wise, it's quite simple, actually. Yeah, so you have different users interacting with different kind of systems. Usually you have the main inspection and maintenance management system where the technical field service gets his task from. You have the site managers who are looking at that area. Then you have the operators who would be interested to have, this digital twin kind of information I've just shown with Cognite, for example. And then you have those people who drill deeper into the data processes and want to understand better how the equipment behaves, have their chemical, their process knowledge, or manufacturing automation knowledge, and want to really see what they can tune to increase efficiency. And then you have your existing OT systems, right, that are giving IoT sensor data. And then nowadays, the new one, you have a robot as a powerful sensor providing data to such a platform as well. And then you have a robot platform to control, survey the robot mission and also survey the execution of those missions. And there are a lot of different solutions on the market, and it's still a growing and emerging field with a lot of startups. Obviously, you have those hardware players providing a mobility platform or specialized sensor equipment payloads on top. And usually we see that across the board, land robots, air, drone robots, and also water. It's actually amazing how progressed this is, especially offshore and in the sea, to do autonomous inspection. And then on top, you need something software, the robot platform to schedule those missions, to execute those missions. So they are either something from the hardware provider comes in, or software pure players such as energy robotics or Perceptor and so forth come in. And then you have something to do, what you do with the data. There are specialized solutions such as Cognite I've shown you, or Optelos for drones, or Drone Deploy, or if you look at getting high precision 3D data, LiDAR scans with Sin2 and Pix4D to get a very detailed view of a site. And obviously you can do it also on your own, with, for example, cloud technologies. So all the building blocks you have in Azure or AWS to build such a data platform, you can also obviously combine and do your own thing. Usually it's something we get involved in when the client has a data lake, has a data strategy, and wants to embark with such a solution on it. And then on top, you have typically SAP systems for the core maintenance of those assets. So skills and technologies. If we speak about a robotic system, that's already a system discipline, right? So you need all kind of different skills to build a robot or a robotic system. So you have the core structure, the core mobility system, which is about the wheels, the legs, the physical structure of the robot, power system, and so forth. That is a topic on its own, right? Then you have all these hardware components, including what kind of computing you put on top, CPU, GPU for the processing. You have all those sensors that you need to decide on what's the best sensor, and what is also maybe manipulators, grippers, and so forth from a mechanical designing point of view. And then you have a lot of software, and this is where a lot of value is coming in the future, and a lot of innovation happens. So it's about the core robotic and embedded software, so how to create very efficient algorithms that can run on such a resource-constrained device, right? And how to connect that. And then you have the topics of perception, right? So we're speaking usually about camera input, so it's a lot about computer vision. How can the robot perceive its environment? How to do this data processing coming from the sensors? You then have the movement, the manipulation, planning, right? Which is a control task, so how to fine control the robot movements. You have the navigation, localization topic, and then the higher level task planning. So what is the strategy the robot can use to achieve its goals, objective. And then, since we are speaking about service robots, it's a lot about the human-robot interaction, right? So how is this designed most efficiently and most in a human way, so that a robot and a robot can interact and work together. So that's a lot already for a robotics engineer. And usually a lot of progress was achieved by divide and conquer, right? So we had teams working on the hardware. We had a team working on the perception algorithm. We had a team working on the overall strategy, the task planning. And we had a team who does the control. And there's a lot of progress being achieved by that. But what we see now actually is that this gets more and more connected, and that more progress is achieved by connecting this dot. So just to give an example, if we look at grippers, for example, if you just change a little bit the hardware, the mechanical side of things, the control algorithm obviously completely change, and also the way and the complexity of the perception changes completely. So all the things are actually very much interconnected, but treated in the robotics discipline until now very separately, or in a typical robotics design project very separately. So in the future, what we see more and more is that this takes a full-stack roboticist profile. So somebody who really understands all of those interactions, and without being an expert in one of those areas, in all of those areas, because it's not possible. You can't be an expert in all of those areas, but you need to understand those interconnections and design the requirements and the robotic system in a way, and also the process you're using for the robot in a way that it's actually feasible and working well. And let me even extend that. So we as Accenture are not only looking at one robotic system, but we are looking at actually enterprise landscapes of robotic systems. And we are dealing with how to deploy software to that robot, right? How to ensure quality assurance, how to do the security things, right? What to do with the data, like explained with Cognite and computer vision algorithms. We are looking at the user experience, not only of the human-robot interaction, but of the entire user experience of industrial work at the site, maybe. Yeah, we're looking at the IT infrastructure, how to do connectivity, how do we connect IoT devices to it, right? We are looking at the enterprise integration. How does it work in a data platform the client has? And obviously, we need the industry expertise around that, because logistics is completely different than process industries. It's completely different than retail and so forth. And then obviously you need to put that into context of business strategy and how it looks like. So we're engaging those kind of engagements not as a single robotics guy or a girl, right? But it's really a team of robotics system engineers in an enterprise environment. So we combine those expertise of different people together to actually tackle those kind of challenges for a client in a specific project. And let me explain give you some examples. So this is also the demo at the booth outside. Yeah, there's this little turtle bot driving on the table. And it's one example of a technology stack that's used in such areas. So here we are used this ClearPath turtle bot with a Raspberry Pi on top. Here we combined this with cloud computing technology. So we are using AWS. There's a snow cone device. It's the smallest edge device you can get from AWS. And then there's a lot of software obviously running on top. Yeah. So in that case, we're using ROS. We have a Python. We are using some OpenCV for the computer vision part. And for the pipelines, we're using GitLab. Yeah. And we have a React front end for the fleet control. And then all this AWS IoT services to get the data from the robot, do device management, do over-the-app updates to it. And on the connectivity side, we're using MQTT. We have a 5G campus network in Garching that we are using to connect those robots. Yeah. So that's just one example. The technology stack. Another one is we participated the Robothon this year, where we are working with the Franca Emica robot arm. We have an IntelliSense 3D the depth camera. We have then a big Linux machine with a powerful NVIDIA GPU. And on top, again, we have AWS. And in that sense, we're using AWS for simulation purposes, because even such a big machine, if you start simulating a robot and the physical movement, you can simulate one robot and maybe two, but then even there, it's at an end. Yeah? So you need the cloud to actually scale the simulation and be able to do that. And here we used Unity for 3D and for it's a simulation environment. And that's actually with AWS RoboMaker. They realized they made this feature available that you can use Unity, and not only Gazebo in RoboMaker to do simulations. We have some, again, OpenCV for computer vision processing. We are using a lot of ROS, and I will get to that. Also move it from that and Arvis. One example, or few sentences on ROS. So the robot operating system, that's a very big framework around open source in robotics. Probably whoever works with robotics knows about it. And first of all, it's not a robotic operating system, but it's a collection, it's a framework of tools that's providing hardware abstraction, that's providing means for communication and enablement of developers. So it dates back to 27. And even since 2015, there was the first publications of ROS2. And ROS2 right now is really something that is ready for enterprise adoption. There's real-time communications, and we see also commercial products using ROS. For example, automotors, they're the industrial arm of ClearPath, so providing really industrial-grade AMRs running on ROS. Anybody is using ROS. We have drone companies who are using ROS. So this is really now becoming the Eclipse and Linux for the robotics community, and that's where also a lot of talent comes from universities around the robot operating system. Not going into details of the features here, but it's really a middleware solution for robotics that's worth to look at. And then let me show you one example regarding simulation and connecting to the metaverse. So here on the bottom left, you see the physical Franca Imica robot arm that is moving. And on top, you have seen, you go back, on the top, you see the Unity, basically shadow of the robot in the metaverse, right? And then here you can see the RoboMaker interface on AWS, and you see the Unity simulation, and there's this turtlebot driving in the metaverse, but getting real LiDAR data you can see there from the virtual environment, right? So imagine how powerful that is. You can now train your localization algorithms, your robot manipulation algorithm in a virtual environment, get the training data from that, and deploy that to the live demo, to the live robot in the real world. Or what we have seen from Christian before, right? We can program the robot remotely, teleoperate it to do what it needs to do without being there and physically guiding the robot or programming some PLC logic. Another, so that is the tech stack for that one. Also ROS2, Unity for the simulation, RoboMaker, and then also all the software development pipelines we see from software being deployed, also being used here for robotics, because you want to know which version was deployed to the robot, which configuration file, right? Which machine learning model, which data model was behind. So you have proper versioning, and you can on the fly update the software running on the robot. And with that, thank you for attention. And I think it's great times for software engineers, for roboticists, for electrical engineers to build those platforms and solutions for advanced automation. And make sure to check out our booth with more robotics demos outside. And thank you.
I would like to just remind you, if you be so kind, we have already able our sorry. Yeah, if you could just fill our feedback form in our page OpenSlava.20, be really great. And now we can continue to Slido and questions.
I can see question on the time saving on the Hamburg Harbor case. Yeah, so before it was really 2 days, 48 hours. The train was stopped and out of operation. And here we were able to reduce to 8 hours. So really the whole inspection was only taking 8 hours. Another question, what do I need to become a robotics full-stack engineer? So I think it's what we call this T-shaped profiles, right? So really one depth knowledge in one of those areas. Yeah, it can be manipulation, it can be mobility, it can be task planning coming from computer science for robotics, and then extend really the broader area around the other topics. And usually, as you know, then the innovation happens in the software from our point of view. That's usually you need really good software engineering skills. And obviously, we know about the relevance of AI, perception in that, ongoing optimization, data skills, and knowing enough about how to deal with data machine learning. That's obviously a good skill set from my point of view. So there are two options. Robot will fully overtake production, or people will still be involved in production. Your thoughts? Maybe I don't think that's true, right? Because it's not going to be a big bang and everything will be automated and we have a dark factory, but it will be gradually innovation, right? And what we are looking into also how to bridge this last percent of reliability, right? So in a manufacturing floor, you need 99.9%, right? Because otherwise the conveyor belt stops, right? And nothing moves anymore. But the truth is, with advanced solutions, you need ways how to get to 80, 90%, right? And then cover those 10% that are still off, and they are telepresence and teleoperation things are very helpful to that. So how can a human help to make a robot to make a decision, right, in edge cases? Because this is happening. If you look at palletizing, for example, there's always one box that is off, right? Can we leave that for the human to deal with? Yeah, can a human remotely help the robot to pick this up? These are things we need to look at, and this will be not a black and white thing from my perspective, but really, especially in service robotics, a human and a robot collaborative exercise. And then, what are the advantages of being able to train, control, access robots in the metaverse compared to doing it in real life? So, obviously, if you look at application of AI needs a lot of data. Getting this data from real life is very expensive. Yeah, you need labs setups, you need physical setups to get this data. Doing it virtually can really much accelerate that journey. So that's one of the key things, and obviously doing it remotely, not being there, is also already very helpful. These things from my point of view.
Yeah. Any other questions from the audience?
Okay. For example, if you look at healthcare and lab setups, where usually a human is not allowed even in the laboratory, and you have today maybe some windows, right? And you need to operate the robot remotely, right? That are first things. Then, if you go in areas where a human cannot go during operation, right? We have chemical processes where you cannot enter during operation. And then what happens if the sensor value is off? They shut down the process and a human walks into, right? But in 9 of 10 cases, there was actually nothing wrong. Yeah, we could have sent in the robot to check if that's a wrong reading and stuff like that. And also, if we look at, there are different levels of remote control, right? You have this one-to-one mapping of steering the robot, yeah, and there are cool stuff. Also, you get really feedback, physical feedback from remote. The robot, but then you can also do remote operation on a higher level. So look at algorithms where you make a decision for the robot, and then it goes back to autonomous operation. Yeah. So these are the things we need to look at, and not necessarily of one-to-one steering of a robot remote.